Hi, everyone. Welcome to my talk. My name is Ann Kuo, and I'm from SAS Technical Support. Today, we are going to talk about a challenge that every support organization faces, the inbox. We call this journey inbox to inside. And the story is really about taking something really messy and unstructured, a very busy support inbox, and turning it into something structured, actionable, and easy to route. I'll walk through the problem and the approaches we try, what we learn, and how it fits into a broader decisioning workflow. Is it working? I don't think this is working. Is it working? Sorry. Oh, there you go. It's not forwarding. Can you help me with this? Okay, let me use the computer. How do we forward this? Sorry. Here you go. Is this? So this should work.
Yep.
Sorry about the glitches, but anyway, let's start with the problem. In technical support, not every email comes in is a support request. Some of them are legitimate customer issues, and some of them are misroutes, like airline-related emails, and some of them are spam. But they all come in the same way, just text. And so before we really start working on a customer's problem, a very simple question we must first answer. What type of email is this? And this means that we need to manually reviewing each email. And this is really not something scalable. And when the system gets really busy, the support queue gets built up. And consequently, we might run into a risk of breaking SLA. You all know that we have agreement with customers that we need to respond in a certain amount of time, and also increase the cost of support. But most importantly, this is really stopping we from helping the customers earlier. And for this work, we used historical support email data in a control environment. And we simplified the problem into 3 categories: spam, SAS airlines, and other, where the other category means a legitimate email request from the customer. And from the very early on, we know that data privacy is one of the key considerations for us. So we did all the work in a restricted environment, which get decommissioned after the work was completed. So the goal was not just to build models. The goal is to build it in a way that it aligns with the production and governance requirements. So let's look at a few examples to make the problem more concrete. The one on the right is a real customer inquiry. And I support Model Studio, so I saw it immediately. I know it's a request to helping resolving an issue for scoring in a production environment. The one in the middle, surprisingly, we've seen it a lot, is a misroute, which meant to be sent to SAS airlines. The one from the left is something we don't want to end up being our support queue, which is a spam. So the goal is not really just classification for its own sake. The goal is to take every single type of email and route it to, to the correct actions whether it is being filtering it, redirecting it, or routing it forward. For this work, we defined a classification task very deliberately. The model predicts the intake categories from the first inbound email body only. So this means no attachments of emails or header information or conversation history is used as input. So this is really about early decision making. Can we detect misroutes and spam early so the real customer cases get routed correctly, faster? And this early step is where the operational value really begins. To prepare data, we use historical support email data in a secure environment and to train our model. And we use the metadata of a Sirius application, which was the former support tracking system we used until we switched to ServiceNow and CSM platform now. But we use that metadata to construct the target classes. And this provides us a very practical way to train models at scale without labeling everything manually. Imagine 100,000 cases I need to label, but we have that information in our hands, so we can do that very quickly. And from very early on, we noticed the data is very imbalanced, where the majority emails are real customers' issues, about 78%. And surprisingly, we had nearly 20% of spam in our serious traditional data. That's quite high. And then we do have a little bit portion, like 2.4% are SaaS emails related emails. What does that really mean? I think there are two implications. First, when we later create sample data for the training, we have to adopt certain sampling methods that help us to preserve the target class proportions to avoid data bias in the sample data for training. The second implication is the overall accuracy metric should not be the only metric we look at for model comparison. This is because you can just give a random model that predicts everything to the other categories, and that'll give you 78% of accuracy. And what should we look at? Think about it. The cost of misrouting a real customer's issues to some other categories is pretty high. The cost of it is higher than the accuracy number itself. So we want to look at the misclassified cases or the error rate associated with it. We explore two very different models approaches for this work. The first one is a rule-based model, which is available in SAS TextMiner in 9.4. A rule-based model is through the text rule builder node, which gives you transparent and easy to understand rules for prediction. A simple example is flight and booking will classify the incoming emails to SAS Airlines categories. One thing is challenging to me, I think to a lot of analysts, is that it requires NLP pre-processing steps. And for those who has been working on those projects, similar projects, you know that you have to deal with stemming, part of speech taggings, stop list creation, synonym creations, non-groups, and entity extraction, all that. And everything you change that, the model will change. So for my personal experience on a lot of projects is that it's very iterative to try to get a better model from that. The other approach we tried was a transformer-based classifier, which is available in SAS Visual Text Analytics on VIAP. And this model, this classifier, is based on Google's BERT architectures, which learns patterns from label samples, and also it captures the context in a more natural way. And one just blessing from using this model for me is I don't have to worry about the NLP pre-processing because it will just take care of the word variations and context itself. And also, another advantage is you can deploy the model into VIA workflow, which is our plan as a broader picture for the decisioning workflow. To train the transformer-based model, I'll give you a sample code here. Basically, you use train test classifier action. It is so straightforward. You just specify, your input table, what your target class variable is, and what the text variable is. Maybe give a proportion for validation and training, and you create a model. So the model out equals option to a Caslin. And notice that I didn't do any auto tuning. I didn't do any specific configuration for this, for training these models. And for this work, I trained two models. One is using 20% sample, one is 30% sample. And I did train with one GPU. Also, I noticed in the log, when I first submitted this job, is how fast this problem converged. At the third iteration, I get a validation accuracy of 96.67%, which is really amazing, and it took less than 43 minutes. And one practical lesson to give away is, when I first submitted code, I thought it would take much longer. So I stepped away for a quick walk, and halfway down the way, my admin called me. He said, hey, your job's finished. Come back. I'm going to take down the system in 15 minutes. Guess what? Did I make it back? Hell no. So what I had to do is retrain next day and make sure the model is saved. So make sure you have the code in place to save your model so you can do a scoring with the score test classifier action on the holdout data. To train a rule-based model, you have to use SAS Enterprise minor interface. And you can see that you have to build all the nodes and flows to compare the model. The text rule builder model, really, the node requires some nodes before that, like text parsing, to do the NLP preprocessing work, and also followed by a text filter node. Anyway, I used this multiple flows to create a champion model. And I think the model was based on a 30% sample. So when I score with score data node on the holdout, which is about 70,000 emails, it took forever, so I canceled the job. Maybe I just have an application running on my desktop. It's not a real powerful server. But I just decided I have enough scoring time given, and I'm going to validate on the validation part of the data. So how do our models perform? The transformer model is so impressive. For both models, they all give very high accuracies, nearly 96% above. And like I talked about previously in the previous slide, that we need to look at the error of misrouting real emails to different categories because the cost is much higher. And misrouting to SAS Airlines, the error rate is less than 0.2%. And the misrouting to sample, span error is a little bit higher, about 1.5%. So the total is about 1.7%, which is really good. And I think it's because the spam data is naturally more noisier, so noisier, so it's harder to capture the patterns, while the SAS Airlines patterns is easier for the model to capture. And on the contrary, the text rule builder really didn't do very well. And you can see the overall accuracy is less than, 100 minus 10.37 and less than 90%. And most important is the error rate is too high. The misrouting of customers' emails to different categories is reached more than 10%. So 1 out of 10 customer emails is going to go to a spam or a SAS airline folder. And I don't think you guys will be happy if I just send you a folder without, really addressing your issues. And let's look at something very interesting from the transformer models. So I want to understand more about why, the model misclassify legitimate customer issues to different categories. So I put out a few samples. Clearly, example 1, example 2, the model was right, but our agent marked it incorrectly as a real legitimate customer issue as other category. And the third example is in the gray area. This email is likely generated by our system. So it's not the real first inbound email from the customer. And in the new production environment with ServiceNow, this is not going to happen. We're not going to have this type of process. So what I discovered is the model started to find human errors, the labeling error in data, and that is so impressive. I didn't really expect that. So is this an easy winner? Which model do we pick? Of course, it's the transformer model for all of the reasons here I just discussed. But like I said, it has minimal pre-processing steps required, which is just such a relief for me personally, because I don't have to spend days or weeks to polish, to go through the text parsing node to get it right for the models. And also, it fits in the native VIA deployment path. That is our overall project required. So before we move to production, there's a possibility, I was told, that we only have CPUs. So I said, okay, let's run some performance study on using CPU only, because we didn't have a GPU. Sorry for yeah, but anyway, so what we noticed is that the latency dropped very quickly once the batch reached to 20 emails. And it only takes about 0.5 to 0.6 seconds per email to score. So it really means that it supports real-time or near real-time scoring without GPU for inferencing. So all the work we just did was just for prototyping, because we use the serious email data, and that's historical. It's not the current data. And we confirmed the performance and feasibility of deploying this model. But moving forward to the production level, we need to retrain. And we have an even higher standard for data privacy and GDPR alignment from our legal requirement. So when we retrain, actually we use summarized data, and which is make sure that we don't have any PII information used for training. And in the, when we go to production paths, also I want to let you know there's a new procedures actually does something we use with the train text classifier action. And this new procedure actually give you a store for model deployment. So you can take it to different environment and maybe different, in the future, I hope, outside of VIA for deployment. So this is how things fit together. And I'm not going to go through all the details of every steps, but from the top level, here's how it works. So ServiceNow will send emails to a controller components where we do summarization or transformation of the data, which gets sent to SaaS VIA environment, where multi-model pipeline running inside VIA environment. And you can see our model fits in step 3 for classifying spam, airlines, or not spam. And it's right at the beginning after the decisioning pipeline start kicking on. If it is a spam airline, it goes to the last step. It goes straight back, say, hey, we're gonna do some other action with those things, with those emails. But for those emails are real customers' emails, it will go down to step 4, 5, 6, 7 until a group gets assigned for taking customer issues. So we have an intelligent way to find the right team who specialize on the problem based on the first incoming email to really speed up the process. Because without we might have to take multiple different teams to identify which team is supposed to take care of customers' issues behind the scene. Oh, sorry, one word about this is this work, the orchestration work, is performed and done by my colleague, Mark Price, and who will be more than happy to give you a demo for this orchestration work at the SaaS booth in the Innovation Hub. Please do stop by, where I and Mark will both be there in the afternoon to explain more on this orchestration. So before we close, here are the key takeaways. And truly, ultimately, we're not really just classifying emails. We are turning them into structured, actionable insight. That concludes my talk. I'll be glad to take any questions. Thank you. Yes.
I just had a question about that last diagram you showed, that you're integrating with ServiceNow?
Yes.
And where do things go afterwards? Are you able to, just disposition things as completed if you're confident that they're spam? And do you route other stuff to review queues, or,
Right. I think in the real production environment, we want to do it carefully first. Mm-hmm. So the way I understand it, we create a flag in our case to flag it that as a spam or airline. Just like if you are a radiologist reading an X-ray and you want to run a diagnosis, and the AI tells you, hey, there is something suspicious here, perhaps it's a tumor, but you don't want to just use the AI to tell you that that's what is happening. Maybe one day AI will replace human. But that's a great question. For now, we want to be careful until we're pretty sure the model is working.
Okay, so you're going to keep a human in the loop, just let them...
Still, yes, human in the loop, that's great,
okay.
Yeah. You have a question? Yes.
Thank you so much. Is the goal for this type of model to be integrated with email applications, Gmail, Outlook, through some type of API so it can be used in the workforce? And where does that look like so far? Like, where are y'all at with the production with that?
So it is through ServiceNow. It's only emails type of data. Of course, we have customers using the portal that don't go through the emails or the call in or anything else, but we only treat the emails data. And it's, so when you submit a ticket through email, you say, that I think the destination is support@sas.com, and then that's the channel that send either through Outlook or Gmail that comes in, and we will process it through the controller so that it will be, data can be used for prediction. Because in my work, I only use the first inbounding emails. I don't even look at the history of the case. We don't have time to do this. We want to do it early and quickly so we can decide who is supposed to take care of customers. So that's the overall picture we try to do. So it's not just classification. It's really production, quick to the action kind of project.
Thank you so much.
Thank you.
Hey, love the session. Oh my God, that's loud. Love the session.
Thank you. Thank you.
I have one question about that diagram on the bottom there. So we have ProctExpert enabling the classifications in step 3. Is there a future where we can use the same approach to classify things in steps 4, 5, 6, and 7? So for example, we could train a classifier to determine whether tickets that are already valid and not spam or airline, whether those are related to 9.4, VIA 3.5, or 4, and then basically improve our accuracy of where we send the triage tickets to.
So are you asking that we should combine all the steps in step 3, or are you asking
Separate classifiers, yeah.
So yes, we do have, that's what we call multi-model pipeline. But the first one, my model, it was, the point is trying to get rid of spam and airline. So like the 78% of the emails that goes through more processing. Actually, we're enriching the metadata of each case, where it is classifying which product is a usage or installation and, other type, and, it's a 9.4 or 3.5, the versioning. So there are multiple models, but they're all deployed into the whole intelligent decisioning pipeline.
Gotcha. Awesome. Thank you.
Thank you.
This is just for my own education. What is Playwright that's referred to in the Python controller?
This one? Okay. This is not my work, but I think the Python is used to, I think my colleague, he wrote Python code. And to communicate with ServiceNow, it was HTTP to request all the emails from the ServiceNow. And he probably used some service to summarize or transform the data. Remember I said we don't want to use raw data. So that's what it's used for. And also it sends the data to SAS VIA. So current implementation, I think it's all running in CAS actions. But eventually, I think we want to convert it in more like a SAS, coding kind of approach than just using Python. And I think he uses SWAT. I don't know if you know SWAT. It's communicating from Python to CAS type of work for like training or scoring, that type of the job that needs to use programming approach. And go stop by, talk to Mark. He will show you, here's an example of incoming, and here's all the prediction from 3, 4, 5, 6, 7. So do stop by this afternoon at tech support booth, and we can give you a demo. Oh, please.
Board have a multiple version, like a multi-language version. So can you use the different board version?
You're saying, the bird support multi-language instead of
Yes.
just, okay. So that's great.
Yeah, there are different boards, like Distil board, the word for multiple languages?
That's a great question. I think the version I used, the text classifier, it was for English only. I read the documentation, it's for English only. But, however, it's very interesting. I saw it predicts really well with Scandinavian language because SAS Airline, I've seen a lot of different languages in, maybe using similar like English or Latin type of language is okay. I can't guarantee it does well for double character set language like Chinese, Japanese, or Korean, because I think we have very few samples from that. So they did say in the documentation it's for English only, but I appreciate that you tell me that we can have BERT models. I'll take it back to the development to ask them if we have features enhancement to support multi languages. Thank you.